Hi class, in this lecture here we're going to continue our study of conic sections by talking about the hyperbola, and we're going to work through three objectives in this class, in this lecture here. We're going to locate a hyperbola's vertices and foci, and we're going to write equations of hyperbolas in standard form, and we're going to graph hyperbolas centered at the origin. Now, if you remember from my previous lecture on ellipses, I talked about how you graph ellipses not centered at the origin. So I'm not going to focus on how you graph hyperbolas not centered at the origin in this lecture here. That's going to be a self-study component for you if you're interested in it, but I will not assess it. So all the hyperbolas we discussed today, or that will come up in homeworks or tests or quizzes, will all be centered at the origin. All right. So let's start. What exactly is the definition of a hyperbola? So a hyperbola, forgive me for studying there, is a set of points in a plane, the difference of whose distances from two fixed points called the foci is constant. All right, so let me try to explain that. So you have two points here, all right, and these are called foci here. And what you can see that's going on here is, and you have this one line, this first green line we'll call D1, and this second line called D2. Notice how they're each getting bigger, but if you were to take their difference, it would stay as a constant number. So this value, this distance minus this distance would be constant, okay? And that's all hyperbolas. It's all the points such that difference here is constant. And you'd be two sides too, because if you had focused the long side, the focus from here to here and here to here would be constant. So basically what I'm saying is, if you take this distance, okay, this would be D1, D2 to this point, it's the same, okay? So this D1 minus D2 would be the same as this one here. This would be D3, and this would be distance 4. Okay, they're all the same value here. All right, so when we go to graph these, what's going to be important, okay, is the center will always be the origin, and it's going to be really important to find these things called the vertex, because you can see what's going on here is it kind of looks like two parabolas, flipped on their side, okay, like this. So what we're going to be able to do, or what we're going to look for, is we're going to look to find these vertex points, and those are going to really, really help us very, very quickly sketch the graph of this. Okay, so going forward, the line through the foci intersects the hyperbola at 2 points, and those are called the vertices. Okay, so what I was saying here is the line, okay, through the foci, like this line here, all right, intersects the hyperbola at these 2 points called the vertex. So think about it as the turning point of both of these curves, okay? So the line segment that joins the vertices is called the transverse axis, and the midpoint of the transverse axis is the center of the hyperbola, okay? And so the transverse axis just goes from here to here, and the center of that is the midpoint of that is the center of the hyperbola. Okay, so in this lecture, just so we know, this lecture only looks at hyperbola centered at origin. Okay, self-study again for not centered at origin. So the equations here, all right, in standard form of a hyperbola, this is with the origin at the center is given by the following. So there's two types here, okay? You could have x squared divided by a squared minus y squared divided by b squared is equal to 1. Okay, that would be the case where the hyperbola looks like this. Okay, so what's going to determine this is the value of a. Like is a squared is always going to be larger here, or not necessarily larger than a squared, but what'll be determined here is where the negative is. Like if you have x squared first minus y squared, it's going to be a hyperbola that looks like this. But if you have y squared divided by a squared minus x squared divided by b squared, then the hyperbola is going to look like this, okay? So this is when the x squared term here is positive, and this here is where the y squared term is positive. Okay, and that'll determine which, how it's flipped or how it looks. Okay. You can notice here then, just like with the ellipse, I have these values C where the foci is. And so the vertices are A units from the center and the foci are C units for the center. So for both of these equations, it doesn't matter if it's x squared divided by a squared or y squared divided by a squared. All right, you'll have this. This is how you're going to help us find the foci. You have b squared is equal to c squared minus a squared, or equivalently c squared is equal to a squared plus b squared. All right, so we're just going to do some examples now. All right, and so the first one here, what I want to do is I'm going to give you this equation, and I want to find the vertices and locate the foci for the hyperbola with this given equation. And you can see here I have the graph here, so you can kind of see it already. Okay, you can literally look at it and see what the vertices are. But notice that 25 and 16 are these perfect squares. So I'm going to rewrite as the following. So I'm going to rewrite this as x squared over 5 squared minus y squared over 4 squared is equal to 1. And right off the bat, you can see that it's this equation right here. Okay, it's x squared over a squared minus y squared divided by b squared is equal to 1. So what I'm hinting at here, the information you're given 5 is a, so a is equal to 5, and b is equal to 4. So you can use that right off the bat to find the vertices. So going back, my vertices here, because the x squared, it's x squared over a squared minus y squared over b squared. My vertices are going to be negative a comma 0 and a comma 0. So look, my a is 5. So this is negative 5 comma 0 and 5 comma 0. And you can see that right here. All right, so now the foci. So the foci occur at, looking back, negative c comma 0 and c comma 0. So how you're going to find that is you're going to have to use this equation. Look, c squared is equal to a squared plus b squared. So c squared is equal to, well, this is my a squared, 25, plus b squared, well, that's 16. So c squared is equal to 41 when you add those together, or c is equal to the square root of 41, excuse me. So then right off the bat, right there, boom, you can see then the foci are going to be negative the square root of 41 comma 0 and the square root of 41 comma 0. So you can see a lot of this stuff is just like what we did in the previous lecture when we were talking about ellipse. Like, you got the formula. Here the math isn't very hard, but it's just, write down what you're given. What is A? What is B? And then how can I use that to find C? And so on. All right, let's do another one. So this says, find the standard form of an equation of a hyperbola with foci at 0, -5 and 0, 5 and vertices 0, -3 and 0, 3. Okay. So what I find helps me to do this, it's just like, how do I even get started? I'm going to start by plotting the points. One, two, three, four, 5. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So look, the foci are going to be 0, -5, and 0, 5. These are the foci. And then the vertices are going to be at 0, -3, and 0, 3. A little bit of a... Sorry, a little bit of a typo with my stylus there. So look, let me go back and look at the graphs. So what is this hyperbola going to look like? Well, look here. I'm giving you, you can see right here, these, if these are the vertices right here, and these are the foci, the hyperbola is going to look like this. So the equation is going to be y squared divided by a squared minus x squared divided by b squared is equal to 1. So the equation we're going to need is y squared divided by a squared minus x squared divided by b squared is equal to 1. So here's the deal. You know A. A is where the vertice occurs. So it's going to be 3. So you're given A is equal to 3. And with the foci here, this is C. So then what you're going to need here is you're going to need B. So going back, you can just use this. B squared is equal to C squared minus A squared. So B squared is equal to 5 squared minus 3 squared, which is 25 minus 9. Okay, which is 16. So then B is equal to 4. So then you got it. Y squared is over A squared, which is 3 squared, minus X squared over B squared, which is 4 squared, is equal to 1. Or just Y squared over 9 minus X squared over 16 is equal to 1. And we got it. So again, what really helped me here was this graph, okay? That just, looking at this graph here. Okay. Now let's talk about how you sketch them. All right, and it's actually not too bad. All right, to do that, we're going to need to talk about the asymptotes of a hyperbola. Okay, and these are centered at the origin. So the hyperbola x squared divided by a squared minus y squared divided by b squared has a vertical transverse axis and 2 asymptotes. Okay, and those 2 asymptotes are y is equal to b over a times x and y is equal to negative b divided by a times x. The hyperbola y squared divided by a squared minus x squared divided by b squared equals 1 has a vertical transverse axis and 2 asymptotes. And this will be, notice the slight difference here. This is y is equal to a divided by bx. And y is equal to a negative a divided by bx. And so we're going to use those to help us sketch the graph, okay? Okay. So this is what this is going to look like, okay? So as x and y get larger and larger, what happens is the branches of the graphs of the hyperbola approach the pair of intersecting straight lines called the asymptotes here, okay? And you're going to notice here when I look at this is I've got this dotted rectangle in here that's going to help me sketch the graph, okay? And so if we have x squared divided by a squared minus y squared divided by b squared is equal to 1, here this is what your hyperbola is going to look like. And you're going to notice these are the 2 asymptotes, the 2 slant asymptotes here, and your graph is going to butt up against those. Here, if you have y squared divided by a squared minus x squared divided by b squared is equal to 1, your hyperbola is going to look like this. and you're going to use these asymptotes here, okay, to help you sketch the line. All right, notice your equation contains a and b, and to help you plot this, notice I've got 4 points plotted here. I have 0, I have 0 comma a, 0 negative a, or 0 b, 0 negative b, and I have negative b comma 0, b comma 0, and negative a comma 0, a comma 0 to help me form a rectangle here to sketch all this stuff. All right, how you're going to graph a hyperbola using all of that. You're going to locate the vertices, okay? You're going to use dashed lines to draw rectangles centered at the origin with sides parallel to the axis, crossing one axis at plus and minus a and the other one at plus and minus b. You're going to use dashed lines to draw the diagonals of the rectangle and extend them to obtain the asymptotes. Then you're going to draw the 2 branches of the hyperbola by starting at each vertex and approaching the asymptotes. All right, it's actually, this seems a little crazy, all these steps, but it's really not that bad. Okay, so the key is identifying your equations and figuring out what a and b are. Once you do that, boom, 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 you're going to notice it goes pretty straightforward. All right, so the key here, the key to getting these rectangles are these 4 points, okay? So are the 4 points on the previous slide. All right, so we'll do this one here. All right, so let's graph this, and we're also going to locate the foci. All right, so I'll show you how to find the foci. It's pretty straightforward. All right, so the first thing you're going to have to do, all right, notice how the x squared is first, and then it's minus y squared. Okay, so that means the graph is going to look like this. Okay, notice it's x squared first, so it's going to look like this. So I'm going to rewrite it. Okay, so step 1, the first thing we're going to do is we're going to find the vertices. So this is x squared over 36 is 6 squared minus y squared over 3 squared is equal to 1. So look, that means this is my a, and this is my b, so 3. Okay, so the vertices will occur at right here. Okay, so this negative a comma 0 and a comma 0. All right, so that's negative 6 comma 0 and 6 comma 0. But then notice I also said you need these 4 points. So you're going to then want to find these points, this additional point, 0 comma b and 0 comma negative b. Okay? So 2 additional points for the rectangle. All right, so that is 0 comma b and 0 negative b. All right, so that's 0 comma negative 3 and 0 comma 3. All right, let's do just kind of going off this, just so you can see everything that's going on. Let's before we even get to the graph, let's find, using the equations that we had in the previous slides, the asymptotes and the foci. Okay. So this has 2 asymptotes. And look here. One is y is equal to b divided by ax, and the other is y is equal to negative b divided by ax. So we're going back, what was my b? My b was 3, my a was 6. So this is y is equal to minus 3 over 6x, and y is equal to 3 over 6x, which is just y is equal to minus 1/2 x, and y is equal to 1/2 x. All right, now let's find the foci. The foci, going back, all right, I'm going to go all the way back here. It's going to occur at, because we know it's going to look like this, negative c comma 0 and c comma 0. And we're going to find c using c squared is equal to a squared plus b squared. So foci occur at negative c comma 0 and c comma 0. So look, c squared is equal to a squared plus b squared. Well, 36 is my a squared. 9 is my b squared. So c squared is equal to 45, or c is just equal to the square root of 45. So that means my foci occur at negative square root of 45 comma 0 and square root of 45 comma 0. All right. Now we're ready to graph this. And look, these key points right here, these four, negative 6 comma 0, 6 comma 0, 0 comma negative 3, and 3 comma 0 are going to help us sketch this rectangle. And then from there, you're going to notice it's going to fall right into place. And what I have here, if you look in the slides you have here, I have the graph sketched here. So I'm going to show you how to do this by hand. Okay, this is, when you're ready, you can see that this is perfectly done. Okay. So hard doing this by freehand. Okay, so you got to forgive me. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so the vertices, going back, negative 6 comma 0 and 6 comma 0. Okay, so this is negative 6 comma 0. And here is 6 comma 0. Then we needed those other 2 points, okay? 0 comma negative 3 and 3 comma 0. So what you do here, okay, is you draw this rectangle. That goes through these points like this. Now, the asymptotes, what's great is net y is equal to negative 1/2 x is this line here. That goes through the corners of the rectangle and the center. And then this other one here, like this, that's the other slant asymptote here. This y is equal to 1/2 x. And then look, your hyperbola then has to touch through this vertice here. So you're going to go up like this, like this, like this, and like this. And that is how you do this by hand. And you can see here, a little bit better. You can see it right here. And the blue dots there are the foci for this. All right, class. So again, these are just hyperbolas centered at the origin. Okay, so a little bit of self-study is how to do hyperbolas not centered at the origin. And, as always, if you need anything, I am here to help.